Hi, I'm Chris and I'm a technical assistant with the Okanagan Regional Library. Today I'm going to show off this old Armatron robotic arm toy and take it apart to give you a close-up look at how it works. So this toy was first made by a company called Tomy in Japan and then sold in the early 1980s in North America by Radio Shack.
These things are pretty cool because, unlike some robotic arms that have a separate motor for each joint, this whole thing runs off of one motor. It's down in the base here, and it uses a series of drive shafts and gears to transmit power all the way up to the gripper claws at the front.
Now normally these toys ran on two D-cell batteries, the big ones you might find in an old flashlight, mounted in series, that is end-to-end, which doubles the voltage, so the two batteries would have provided 3 volts. I've hooked the battery terminals up to a DC power adapter that produces 3 volts, same as the batteries, which allows me to run the arm off of a 120 volt AC wall outlet instead of wasting batteries.
So I'm going to give you a demonstration of how this thing works, and then let's take it apart and see what's inside.
So just as I was about to start filming, I was using this toy and suddenly the motor stopped working. It was completely dead. So now I think I'll take it apart and I'll talk a little bit about how the toy works, and I'll give you some time-lapse video of me taking this thing apart and seeing if I can find the problem. Then I'll put it back together again. Maybe you've seen video or photographs of the robotic arms that are used to build cars on a factory assembly line. They're like big versions of this with a welding tool attached to the end. Assembly line robots generally have 5 or 6 degrees of freedom. That is, they can pivot or move in 5 or 6 unique directions. Usually they can pivot at the bottom, rotate at the shoulder, elbow, and wrist, and also twist at the wrist. Sometimes they also twist at the elbow. This Armatron toy has 6 degrees of freedom. That means there are 6 unique movements the arm can make. It can rotate at the shoulder, move up and down at the shoulder, bend at the elbow, bend at the wrist, twist at the wrist, and of course the gripper can open and close. The difference between this toy's design and those industrial robots is the industrial ones generally have a separate motor in each joint, the shoulder, the elbow, and the wrist. Each arm could have as many as 6 different motors. This toy's arm only has one motor. So how on earth does it get so much movement out of just one motor? The answer is lots and lots of gears and drive shafts. Let's take a look. There are lots of different types of gears, and the Armatron uses several of them. A spur gear is what you probably think of when you picture a gear. They look like this. A crown gear is beveled so it can transmit power at an angle. Worm gears only allow power to be transmitted in one direction. For this reason, they work well for preventing a gear train from slipping backwards. Sector gears only have teeth partway around, giving them a limited range of motion. The Armatron uses sector gears in the gripper. Ring gears are like spur gears, but ring-shaped and can have teeth on the inside, the outside, or both. The Armatron has a bunch of ring gears in the center that help transfer power to the spur gears that drive the arm.
So as I was filming this, the motor suddenly stopped working. Having taken it apart, I can see that this black wire here that is attached to the motor has become detached. The solder joint failed. So I think that's probably why my motor shut off, and that's something I can easily repair later. But for now, let's have a look at how this thing works. So rather than turning the motor on, I'm just going to rotate the main gear that's driven by the motor by hand. So this is what would be happening when the motor is running. Power is being driven to these gears that are housed within the green gear carriers. Now if I move one of these joysticks, it's going to manipulate the orange pin. You can see one moving on the right hand side as I push the joystick forward. And that's going to cause the whole green gear carrier to rotate until a new selection of black gears comes into contact with this row of gears along the top. There's also another row of gears along the back. So these green gear carriers essentially function as a transmission Whenever I move the orange pins, it changes which of the black gears are in contact with the other gears here along the back that drive power up to the gears that connect to the arm itself.
Now I think I'll put this back together and test it to see if it works.
So I've just resoldered this joint here. This is the lead that connects to the battery. And I'm going to plug it in now and see if it works. Sounds good to me. Looks like we're back in action. There we go. It's all back together. Now I'm pretty confident this is going to work. I'm going to plug it in and see what happens. Thanks for joining me for this quick breakdown of how the Radio Shack Armatron works. I'm relieved that I was able to get it all back together without completely destroying it. There are a lot of little pieces in here and I was worried I was going to lose some. But that motor is fixed now. I've got that contact on the switch soldered back on, and it all seems to be working.
If you like this video, be sure to hit the like button and subscribe if you'd like to see more videos like this. Thanks for joining me, and I'll see you next time.